Yes, welcome to this tutorial. I want to show you how to load files from SolidWorks direct to Mastercam. Then we do setup in Mastercam. We see how you can program using Mastercam using version 2023. So this is the file I want to upload. Show you the file. I want to upload this file in Mastercam from SolidWorks. So let's see how do we upload this file. Then we set the origin. When I designed this part in SolidWorks, my origin I put here. So I want to see, first of all, maybe I can check some of these dimensions that I have. A maximum diameter, for example, here I have a maximum diameter of 32. Then the maximum length is 75. So this origin is almost at what? Check the origin. You can try to check the origin. For example, I can edit this one, show you. I can check, see how much we can go further from the origin to when we upload it. In Mastercam, we're able to also configure the same origin. Okay, from this center, if I want to put my origin here, this is at 7.5. So it is at 7.5. What about the tip? The sharp tip. This is for the dies. So this sharp tip, maybe, for example, it is 5. So that is at 7.5 plus 12 becomes 42.5. So if we can go to Mastercam here, let us go first of all to change the units. Here the units are saying in inches, so I can come here, then I say change the inches. That is from configurations. I want to configure this one, change to millimeter. I'm using millimeters. I think as we like using millimeters. Then once I'm able to set that one, this origin should be there at the center. How do you put it? You can go to view all of these axes, ensure that all these axes are shown. When we click on this one, it will be hidden, so I don't know if it is at the center or not. So you need to show all the axes. Then you can also show other items that you want, or if you want to have to show on grid or not, to show a grid or not, so you can activate or deactivate. Then also you can put sheets. This is the view sheets. You can also put the view sheets on. So once we have done our setup using what you call configuration to ensure that we put our units to be in millimeters, then you can go ahead. So next is, there's two ways. You can either merge or you can open. You can either merge or open. For example, you can click on open from the computer, maybe let's say design files. Then what I do is I want to set my file as SolidWorks. So if you change the file, you have different files you can open. The beauty with Mastercam, it can allow you, if you're using Mastercam, GIPSCAM, they can allow you to upload the file directly, like from, if you have Solid Edge, if you have that is parametric, if you have SolidWorks, we have Rhino, so all of them. Right now we want to use SolidWorks, so I can just come to SolidWorks files. Then I'll scroll down to check which file I want to upload. So this is the file I want it to upload. I think the one I was showing you. I don't know if it is this part or not. Let me see. It's not showing here. The part I wanted to upload, that should be design 5. Is it here? Design 5. Let me close the SolidWorks first. Yeah, this here, this one, then design 5. So click on this one, open. We want to see the origin. Was it design 5 or 4? I already use 4. So let's use design 5. This is design 4. So I can say new file. So we use the correct file we have checked. Don't save this. Again, go to file, configurations. Here to put your units. This one I'll show you how you can put it permanently. You come to your files, come to open, go to design, computer, then designs. So you can open design files. SolidWorks already selected, so ensure that you have the SolidWorks. If you have Autodesk, you can also open Autodesk. For example, you can click on Autodesk, then it can pop up direct to where the Autodesk are. For example, I can click on this one, then it will give me all the files I want to upload in Autodesk. But now I want to use SolidWorks, so I'll just pick SolidWorks, come to design, go to design for number 4, okay, and to see it appears on now. This is what I wanted. When I designed SolidWorks, the origin came here at the center, but I wanted the origin to be at the tip. So what do? We need to orient. If I say top plane, if I change to isometric, you see how it looks like. If I take on top plane, this is how it looks like. The origin is at the center, so I want to put my origin at far end here. So there are different ways we can put our plane. So you can use these planes here, or shortcut way you can come to model preparation, then say align to Z. You click on this align to Z. First of all, let me put to isometric, then come to here model preparation, click on align to Z, then you can click on this part which is close. This one, you see it has already placed the origin at the far end, where the z-axis is pointing away, and then the x-axis is pointing also away to at the origin. So this is the origin. What I do now, I can put here as my plane. Maybe you can say new plane, for example. This is the plane I'm going to use for purpose of programming. Okay. You see now it has changed the origin from here to this origin. So you will come here. This is a new plane. So this plane should be accepted as it is for workpiece coordinate system, for tooling, and also for workpiece coordinate system more grounded at the same point. So this is a new plane I've created. So you can also change the way you want. Then next, I want to create a turn profile. So the next step, let me say level 2, come to turn profile, for example, say enter, come to wireframe, then click on turn profile, click on the part, then say end selection. You can use either upper side, lower side, or full profile. This is the profile. You see it will appear, so that when the tool is cutting, it can either generate if it has the inside or outside. So I like using full profile. Then I click OK. I want to show you this. So in a case I want to hide this, it will show me this is the profile that my tool will be following. If I say show, it will show the 3D mobile model. So that's the beauty of Mastercam. I can hide, I can show. That's why I'm using labels. So you can use labels to create all this. Then you can also either go to maybe number level 3, maybe say now toolpaths. Okay, then I can come to machine. I can pick my machine here. I have the machine here, but I don't want to use this one. Let me use a default one. Okay, the default machine. Once it's a pixel, click on tools, toolpath, then come here, expand, click on tool settings. You can put here the program number to increase by 1 from 1, then ensure that you assign a tool number sequentially, then ensure that the software will warn you in case of any duplicate numbers that has been put in that programming. You can put the material, for example, from tool library. You can pick some of the material you like. Maybe I can use aluminium 775, that is T6. Okay, then I'll do setup here. You see now the plane has come here. The plane we had created using another plane, which we name it as new plane. It has come here, and then I want to do setup. If you have two turrets, you can use left spindle and right spindle. But if you have single spindle, you can use left spindle. In most cases, the single spindle are on the left side. So I can use single spindle. Then I can come here. I want to check by OD is 75. 75 plus 5, that is, let's say, 8. So that is 16, 32, we can say that's 2. Then here the lane you can say 8. Or you can pick or select, for example, on this. You can pick on this, it takes, that's the OD. Then the length you can also pick, for example, you can try to find, that's why I like hiding. So you can hide this one, the file here. Then you can come to this toolpaths. You can click on this. For example, it can show you the length, which is not accurate because we have picked a point. So what you do, you can, before you do that one, then we cancel this one to show you the tricky of doing it. You can right click, then say measure distance. For example, I can pick this one. I can pick this like this. You see, it's giving me 80. You look at this, it will give me 80. That is the distance. So I'm able to know the distance. I can also measure the distance across. For example, this part and this part, it is 42. You see, that's why when you're putting it, give me 42. So then let's go back here, put one aside, then check the material. You can pick your material you want. You say I'm using this, then go ahead to stock. Let's come again. Can pick here. Now our odd is 42, our length is 80. I'll show you how to put. So I can use margin. If it is 42, maybe I have 50, so I can use that is 42 minus 50 minus 42. That is 8 divided by 2, 4. Maybe I can say extend by 5 both sides. Then here I have 2 millimeter for facing. Then for holding, maybe it is 40, for example. Then you can preview. You see, there's this dark smoothed line or the dotted line across. This is our stock. You click enter. Click here, okay. Then come to your chuck. Which side are you holding? I'm using the left spindle, so I'll come here to my parameters and use a simple method. You can grip with maximum so that it doesn't leave a gap. Then here I can say I'm holding at 25, should be 30, okay. Can preview. So when you preview, it's able to show you these are the chuck. So where it will be clamping. Click enter, then okay. And then I want to use the left spindle, ensure that it's shaded, so see what it happens. So this is the profile. So when I come to level, I can click on this one to show everything I want. You see? So this is the target, and this is stock, this is chuck. That is how we set in Mastercam. Then once you do that one, you're able to go to programs. So the setup is very simple. You do a setup. Once you finish this up, you go to programs. The programs are always here turning. So you can, if you're using mill turn, you can combine turning and mill turn. But here I'm using turning only because they don't have milling. Okay. I can do face rough. Okay, face rough. Can pick my tool. Let me use this tool. I like this tool. Let's say OD roughing. Say OD roughing. This is my header. Then ensure that I'm putting a reference point in my program. Can pick somewhere here, example, and say it is coming from 50, even 50. Can you copy the other side? Okay. Then my machine is 3000 maximum, so I don't exit. This was I'm using 400. Then this I'm using 0.22, or they say 0.21. It is okay, yeah. For roughing, okay. Coolant, can activate coolant here, it's okay. You activate coolant here. Also check the turret position. Here you can click on this to check the turret position. Where is your turret magazine? Is it on the upper left or right upper, or left lower, or right lower? So mine is left upper. So okay, so I'm using left upper. Then you can come to this one and check this. Say maybe 1, or let me see 0.8. Maybe it's 1. So the maximum, I can also put tolerance of 0.02. Okay, then I can say generate. So this is the facing. You see it has generated toolpaths. This is the toolpath now that it has done. We go to next is roughing. We want to do roughing. So go to roughing. You can say we want to, for example, here I want to hide is 3D. I mean 2D now. I work with 2D. That's the beauty Mastercam. Then I can come here. I pick maybe from this point, up to this point. For example, I'm picking from this point up this point. Here, the tool won't cut, it will just jump. But I want my tool to bypass here, to just cut here, but not into the groove. I click OK. From there, I just want to pick the same tool, this tool for roughing. So I'll write here OD for my comment, OD roughing. The first one should be OD facing. I think I changed, I put it the wrong words. OD roughing, the same roughing tool. Reference point, I can pick or put just a value. For example, where is my reference point? I can copy this side. Okay, this is 3000. Just normally can put this is 500. This is rough parameters. Show that I'm leaving 0.1. Don't want to leave too much material. 0.1. And then lead out. I want to extend the lead out by 3 millimeter. Okay. Then here filter, I want to put my tolerance 0.02. Okay. I want to show that I use the stock boundary for the purpose of calculating the parameters for cutting, so that I'm able to know where my workpiece is and how it is. So I can also shorten the toolpaths and say calculate. It generates the toolpaths. The beauty with this one, you see, this one I have done what we call lead out. I have extended by 3 millimeter. In case I wanted to do a grooving, for example, I can also edit this one. I wanted to do grooving. Click on this, you can edit a tool. If you click on this one, you can edit the parameters. So I want to edit parameters. So I want to extend the same. Extend here, lead in, lead out. So you come to lead out. You go to lead out. You can extend maybe by 5, for example, or 4. If I want to do parting off, so that you see it has updated. Then this section it won't cut because it has a groove. So we'll do grooving from this side. Then remember we had done we had left some material for finishing. So I want to go to groove first, then I'll come to finish, or I can do finish then groove. So either way. So let me go to finish. Then because I had picked the previous part, I don't want to pick again. I just come here and say last, give me the last tool part, then click OK. From here I can go to the tool. Maybe I want to use this smaller tool. Then I say OD finish, OD finish, for example, finish the reference. I can come here, say let's see 50 by 50, copy this side. Okay, then finish parameter, also lead out. I want to ensure that I have a lead out, the same lead out, extend lead out, like here 5. Okay, then my tolerance is 0.02. Okay, I can come here, this one the way it is. So finish. Okay, then I want to do grooving. Then I rearrange the programs. So let me go to here. Say there is a groove turning. I want to do groove turning. Same 3. Say this is a chain. We have 1.2.3 lines on the chain. I normally use chain, so let me use a chain. Then in case you see this tool profile, too many of them, what you do, you can just hide. Before okay, let me proceed there. Before I do hide, let me go to that one. So I can pick the profile. I can expand here. For example, I can pick here. Then I can say reverse. Then I pick the last one. The last one here. You see? So it is coming all the way from this until the last one. So I click OK. Then what I do, I will pick a grooving tool, the simplest one. I want to use this 1.85. Then you can say groove. This is grooving or groove, whatever. Put ref point here. Put also 50 by 50, for example. Copy this side. Okay. Then here it is one groove is 500, 300. Point this 150. Okay. Coolant is okay. Groove parameters. You click on this OD, then it's 9 degree. You can say use outer boundary, no problem. But I've already done turning, so I don't need to use outer boundary. Come to groove parameters. I want to use the multiple opaque groove, for example. Can put here like 1. Then okay. Can put here it's this one, okay. Can put also filter for tolerance 0.02, 0.2, okay. This is the OD. I want you to leave 0.1. Also here 0.1 for finishing. The stock amount like this. Then this is rough grooving. I want to use this chain direction. For example, I want to use chain way of turning. Then come here. This clockwise. I'm using clockwise, so it's coming from this point or counterclockwise, but I want to use clockwise like this. Then here I can leave the way they are. Here the stock here should be 0. So because I don't want to leave any material, then I click on this generate. You see now it has generated my toolpaths. These are toolpaths. And then I can rearrange. For example, I can say this one should go up here. Move before or after. Move before, for example. So this late finish. Once you move before, it has changed. So what do I do? I can say select all operations. Then here regenerate. Select all operations. Then here say regenerate all the 30 operations. So it will update. So it has now updated. Then this one should come down. This line should come down so that it is the end of the program. This one means the end of the program. Say now select all of them. Then again regenerate. So it will update. So we have done our our programming. Yes. Here, the first operation is we have face. This is our facing. I want to change the parameter, maybe the naming. Here should be OD. So I want to change this one to be OD facing. Okay. OD facing. Second one from our program. If you check a program here, it is OD traffic. So I want to change the names. Then the third one, we have grooving. Can change the names here also to suit this, to have a unique name, grooving. Okay. Then the fourth one here is our finish, OD finish. So I can now click all of these operations. Then I do back plot to see how the tool will behave when it's cutting. So it has how many operations? We have OD turning, grooving, and finishing. There are 3 of them. So I want to do symbol. Let me see if I click on this one. That is facing. Then we have rough turning. This is a die part. Then I'll come to groove. Then it goes to finish. That is finish. Only one pass. So that is what you call backplot simulation. I can also use this kind of simulation. We call it NCI. That is in a simulator. So I'm using a simulator to simulate this. So I want to see how it will also behave when it's using 3D instead of using 2D way of simulating. I can expand here. For example, I want to use dynamic rotation. I want to show you how the tool will be coming. So this is our workpiece. Let me position like this. The blue one is y-axis. Sorry, the blue one is x-axis. This one is the y-axis, z-axis, and then this one is a y-axis. But this one according to the design. But according to the program, it is z-x. So using G18 plane. So I want to show you how it will be doing when it's cutting. Alongside here, we'll see it has different operations. Up to here, that's the facing, then rough turning, grooving, then finishing. So let me play this. You see that is facing, that is rough facing. Then it goes to rough turning. I've not done face finishing, so I've jumped that one, no problem. So this is roughing. So doing what you call OD roughing, outside diameter rough turning. Once it finishes outside diameter rough turning, it will go to grooving. rough, then grooving finish, then the last operation will be now finished. So that in case I want to do part off, I can do part off. Or if you want to turn the other side, I will also do part handling. For this one, we are not doing part handling. So this part is for a die. This is a die part. So we are making parts for dies. So this is the rough turning. It also put a chamfer, because I had to put a chamfer here. You were able to expand this like this. You will see what it does. It has put a chamfer. It has put a chamfer like that. Yes, that's finishing. Then it comes the last operation, only one pass for finish. One pass for finish. I'll put these tool parts to show what how it will appear. This it guides me. In case the tool has not shown me this part, then it means it has not cut the material. So I'm able to see the part here. Yes. So this is what we call CNC part programming, but using computer-aided design. That is, using computer-aided design, at the same time, computer-aided manufacturing. That is integrated software like Mastercam to help you in automating programming. CNC is just a computer numerical control, where you are using a computer that has inside the application softwares, the CAM softwares, to help you in automating programming. So this is what we have done. We have done programming, but this is not the end. Our main objective is to acquire G-code. So before that, let's go to G-code. So once you finish this, you click on select all of these operations. Then you can click on this G1 to post a G-code. Then you can say, okay, post a G-code. Where do you want to save it? Maybe I want to, because my machine is Siemens, I will say .mpf. Then okay, save. Then it will open the program. It will open the program using the Mastercam called expert editor to help you counter check the program before you take the program to the machine. So this is the program we have done. This is our program. So in case this program is okay, like remember how we are doing it. We had put this OD finish. And my tool is right. That is DNMG150608. That is for roughing. Go all the way. It will also give you second tool and also operation. Second tool, because I've changed it has grooving. Narrow, insert, N15, all these are called for insert. Then the last one, it has given me the tool for finishing. I'm using VNMG160408. So this is how Mastercam helps you to automate your programming. So you need to understand the G code before you proceed to program. So this is what I require to put on the machine, so the machine can now run and cut the part. This program can run on GSK machine, Haas machine, Siemens machine, Fanuc machine, unless the syntax error will come when you have not picked the correct controller. At the same time, you have not checked the part program. Once you program, you need to check the part program in case of any error somewhere you didn't do the setting well in the software. You need to check those parameters. Like this T0101, it will also appear, it will read well in Fanuc, Haas, and GSK, but in Siemens, it will not read well. So you need to change this one to be D1. In case you didn't put the correct post processor, but in case you pick the correct post processor, then you don't need to worry. For example, I can open a simple program here. Let me open a simple program. I don't know if we download. So let me check if I have a simple program like this one. Let me check this program. See, this program is now for Siemens machine. This is another program for Siemens machine. So for this machine, it uses T and D. That is tool number, tool offset, and you see the program how it is very simplified, very simplified. This is the program. You are able to also to do backplot using editors, using these editors. So this is Mastercam editor that we have used. In case you have any question, you need to seek for more clarity, you can contact us, you can comment. This is just for learning, but it is what we are doing in the industry. So we are located in Lunga, Nairobi, that's our area. For more details, you can call us, you can come. We help you to do machining.